So, good evening, my dear students. Dr. Arun Kumar Kulshrest conveys his warm regards and salutations to you. And I am a faculty in the Faculty of Basics and Applied Sciences in Madhav University, Pindwara, District Sirohi, Rajasthan, India. And Madhav University was established under the Act number 7 in 2014 by the Rajasthan government, and it conducts a diverse array of programs like uh, homeopathy, physical education, and physiotherapy, and special education, pharmacy, naturopathy, agriculture, uh, and different streams of the sciences like mathematics, physics, chemistry, microbiology, and biotechnology. So besides that, this university conducts BCA, MCA programs and diplomas, BTech and ITI. So many programs are being conducted in this university. And the prestige of this university can be judged by the fact that its chairman, Dr. Rajkumar Rana, will be uh, honored with the Global South Leadership Award on 18 July 2025 in London. So I congratulate all the students taking admission in 2025 in Madhav University in advance and welcome them here. So this is my publication published in the Elsevier, that is the best publisher of the world, you know. So um, so I just to give you some uh, glimpse of my publication at uh, antibiotic drugs from fungi. So drugs from antibiotic drugs from fungi. So you know that there are many drugs for the diabetic treatment. So it's an honor to be speaking to you today on a topic that beautifully merges traditional pharmacology, moderate medicine, and microbiology. So antibiotic drugs from fungi, this is a promising frontier in diabetic management. So diabetes mellitus is a chronic metabolic disease characterized by elevated blood sugar levels. So and globally, its prevalence continues to rise, with millions depending on daily medication to manage their condition. So, despite the range of treatments available, limitations such as side effects and drug resistance and cost still exists. So, this has created a compelling need to discover and develop novel anti-diabetic drugs, especially from the natural sources like fungi, which have long been known to produce bioactive compounds with therapeutic potential. So anti-diabetic drugs help in regulating glucose levels in various ways, enhancing insulin secretion and increasing insulin sensitivity, reducing the glucose absorption or promoting its excretion in the urine. So these mechanisms target different physiological aspects of the disease but are not without challenges. So, so current treatment options. I talk about current treatment options. But before that, I would like to uh, share my feelings about the Madhav University. So Madhav University is UGC approved university, और कुछ ही दिन पहले यहाँ पर नेशनल एक्रेडिटेशन एंड असेसमेंट काउंसिल की विजिट भी हुई है, और सभी फैकल्टीज के साथ भी काफी कम्युनिकेशन हुआ था, और उसमें उन्होंने जब पूछा था हमसे कि कितने लोग हैं जो पीएचडीज हैं, तो बहुत सारे लोगों के हाथ उठ गए थे। और उसके बाद उन्होंने ये पूछा कि हाँ, तो नेट क्वालिफाइड कितने हैं। तो डेफिनेटली काफी इंटरेस्टिंग क्वेश्चंस थे उनकी तरफ से कि इतने जो मेन जो मसले हैं वो उनको उन्होंने हमारे सामने रखा था। सो इस तरह से ये नैक एक्रेडिटेड भी जल्द ही होने वाली है, और इसके अलावा यूजीसी अप्रूव तो पहले है ही। So now I return to my uh, topic on the anti-diabetic drugs from fungi. So there are current treatment options, but you know there are so many drawbacks of the current treatment options. So like insulin, insulin is a current treatment option essentially for the type 1 and advanced type 2 diseases, but requires lifelong administration and precise dosage management. Another drug is metformin. So first line treatment in type 2 diabetes, while effective, it may cause gastrointestinal side effects, and it is contradicted in renal impairment. So another drugs are sulfonylureas. So these sulfonylureas stimulate insulin secretion in type 2 diabetes. So more and more insulin will bind to the reduced number of the insulin receptors. So while effective, but again, they cause the risk of hypoglycemia and weight gain. Other drugs are thiazolidinide ions. So these it stimulates the insulin sensitivity, but have been linked to the heart failure and bone fractures. And DPP4 inhibitors, these enhance incretin levels, improving insulin release. So they are generally well tolerated, but DPP4 inhibitors may cause cardiovascular risks. And like sodium glucose co-transporter 2 inhibitors, they reduce the glucose absorption from the reduce the glucose reabsorption from the kidneys, but can lead to the dehydration and urinary tract infections. And GLP receptors agonists, so they lower glucose and induce weight loss, but are injectable and costly. So all these are drawbacks of the current treatment options. So now I go to the importance of discovering novel drugs. Okay, so these were the all current treatment options uh, about which I explained a little uh, in this video. And importance of discovering novel drugs. So these drawbacks drive the urgent need for new therapeutic alternatives, and especially in natural sources, especially fungi, are proving to be biological gold mines for new bioactive compounds. Okay. So now fungal species of the anti-diabetic drugs. So let's now explore the fungal world and how it offers hope for diabetic treatment. So habitat for the antibiotic, habitat for the anti-diabetic properties. So these fungi are found in soil. So as these the common habitat of the fungi, which are having the property of anti-diabetic. So let's now explore the fungi world. So these fungi are found in the soil, and we can find these fungi on the decaying matters also, and the forest ecosystems, and even endophytically inside the plants. So their biochemical diversity is shaped by their complex habitats. And many species from genera such as Penicillium, Ganoderma, and Aspergillus and tree have demonstrated antidiabetic activity. And these fungi can be cultured in laboratory and industrial settings to produce extract or purified compounds for study and drug development. So uh, new, producing new or novel compounds for diabetic treatment. So fungi produce several secondary metabolites, including the polysaccharides, terpenoids, phenolics, which have been shown to lower blood glucose or enhance insulin sensitivity. And extract and tinctures of medicinal fungi are being explored for the direct use or the formulation into therapeutic products. Solvent-based extraction from dried fungal biomass is a common method, and inhibition of alpha amylase and alpha glucosidase. So many fungal compounds inhibit carbohydrate digesting enzyme alpha amylase or alpha glucosidase. So these are since involved in the elevated levels of the glucose in our blood. So these fungal compounds inhibit these enzymes alpha amylase and alpha glucosidase. So thereby showing glucose absorption and controlling postprandial spikes. After eating the food, there are spikes of the glucose level. So mushroom extracts as enzyme inhibitors, species like Pleurotus and Agaricus have shown promising enzyme inhibitory activity in vitro, making them potential functional foods or nutraceutical for diabetic care. So, Penicillium xanthinaceum polysaccharides derived from this species of the fungus have demonstrated glucose lowering and insulin modulating effects, making this species a candidate for drug development. And now we see the uh, we see the uh, uh, hypoglycemic effect of the Ganoderma lucidum 5.9. So hypo that means the effect of the Ganoderma on the glucose level. So it can reduce the Ganoderma lucidum, which is mushroom. So it can reduce the blood level. So it acts as a hypoglycemic agent. So perhaps the most researched is Ganoderma lucidum, also known as Rishi. So in India, Rishi, So its extract contain ganodiarins and triterpenoids. These are the chemicals. Ganodermins and ganodiarins and triterpenoids, which are effective in lowering the glucose level. So that improves glucose uptake by the cells and regulate insulin signaling. So they can increase the insulin signaling and provide antioxidant protection also. So Ganoderma lucidum is a wonderful mushroom which can be cultivated in the households also. And besides that, endophytic fungi and diabetes. So endophytes fungi living within plants. So these are the fungi which are living inside the plants. Okay, so are also being explored for lowering the blood glucose, solving the diabetic problems. So they often mimic the host plant's therapeutic properties and produce compounds with glucose lowering effects, making them untapped sources of discovery. So anti-diabetic polysaccharides and in extracts of uh, in in at, anti-diabetic polysaccharides and triterpenoids in extracts of Ganoderma. So recent studies highlight that polysaccharide enhance insulin sensitivity, while the terpenoids, while these terpenoid act as through multiple pathways, including modulation of glucose transporters and reducing inflammation and oxidative stress. So, in conclusion, I can say that while existing anti-diabetic drugs of relief, they are not without limitations. So, thus, search for natural, effective, and safer alternatives is leading us to fascinating kingdom of the fungi, like mushrooms or the penicillin, xanthinellum, and others. Okay, so hold immense potential. So fungi, especially Ganoderma lucidum, Penicillium xanthinum, hold immense potential in shaping the future of diabetic management. So with further research, standardization, and clinical trials for fungal metabolites could revolutionize the diabetic therapy, not just supplements, but possible in mainstream drugs. So thank you for your attention, and I invite the audience for questions and discussions in the message box. Thank you so much. Good night.